Hello everyone. So here is a discussion on Indian climate. Right, it's a very important topic so far as your mains is concerned. Right, it's a very important part of your optionals and important part of general studies as well, because the significance of Indian climate is immense so far as agriculture is concerned, because after all Indian economy is an agrarian economy. Right, so from the economic significance of Indian climate and primarily Indian monsoon to Indian festivities, it is very important to understand the mechanism of monsoon that characterizes Indian climate. So having said this, let us start with what is Indian climate like. In this discussion we will also be describing the mechanism of monsoon, theories which suggest the origin of monsoon, and also discuss the distribution pattern of Indian monsoon. Right, so let us discuss this point. First, when we talk about the Indian climatic condition, it's primarily monsoonal. But if that is an associated seasonality. So when we talk about Indian climate, there is one aspect associated with it, that is seasonality. There is a significant change with the changing seasons in India. So therefore we call Indian climate as monsoonal type. So what is monsoon and how we relate to the monsoon? Let's discuss one by one. So related to the origin of monsoon, see, there were many travelers who have visited in different parts of India in different times, and the significance of monsoon for Indian climate was always known. If we talk about the Vedic times, right, there was some, although the word monsoon did not exist at that point of time, but then the significance of monsoon was always known, and the relevance of Indian Ocean, that is probably the reason why the ocean was named after India. Right, so the significance of the Indian Ocean that it has for India can be also understood when we describe the Arabian Sea branch and the Bay of Bengal branch approaching towards Indian Peninsula. So it was since the Vedic times that significance of Indian Ocean is known for India. Right, but it were Arabs who were great travelers, and many Arab travelers visited India. Right, and one of the prominent name that is there is Al-Masudi and later Al-Bruni also. See, there is one inquisitiveness to understand Indian climate, because when you look at Arabian Peninsula, it's tropical, so is India, but India receives heavy rainfall and Arabian Peninsula does not receive so much of rainfall. It is also surrounded by sea. So many geographers, many travelers who came to India had one question in mind: what causes rainfall in India? So Al-Masudi observed that the direction of the wind is southwest to Indian Peninsula, right, and same region, direction of the wind is northeast during winters. So this is the winter time, rather this is the winter season, direction of the winds during winters, and the direction of the wind during summers is towards southwest. So what they observed, that there is some kind of reversal in the direction of the wind. Winds are southwest during the summers and they turn back, rather they take a U-turn as per them and then become northeast. So anything that changes, right, that shows the change in the pattern, they called it as monsoon. A Malayalam word right? So the term means that they referred monsoon was primarily, it meant to change. So what did they observe? What is changing? Right? What is changing actually? The direction is changing. The direction is reversing. So there is the time when the word monsoon comes, it later becomes monsoon. So that is the Arabian influence on monsoon, right? Making it popular, and the term monsoon was given to it. Now let us discuss origin of monsoon one by one. Theories related to the origin of monsoon, and one of the earliest concept related to the origin of monsoon was given by Halley in his thermal concept. And before we go to the concept, what Halley has said, see, you know, after Arab medieval times, there were so many European geographers, because after Dark Ages, a lot of research and scientific research and discovery started. Geography also was benefited because a lot of geographers started explaining different mechanisms taking place on different parts of Earth. And a lot of people, a lot of geographers studied the tropical winds, Hadley being the prominent one. So what did they study, right? And how did they explain the formation of monsoon? There are two viewpoints, two types of theories. One are called as classical theories, second is called as modern theories. So when we discuss these theories, right? So two categories of the theories. One, classical theory. Second, classical theories, and second, modern theories. Right, in classical theories, we'll discuss the thermal concept, right, given by Halley or few more geographers contributing to it. And in modern theories, the dynamic concept, right, dynamic concept as mentioned by Fawn. So first, let's see how did we evolve to the concept of origin of monsoon. See, this concept is very simple to understand. Halley used, the concept was given in 17th century, right? As per the dates, it's like 1686 that this concept was mentioned, right? So it's very old concept. One of the earliest concept to understand theory to explain formation of origin of monsoon. This theory says that monsoon is a land breeze and a sea breeze phenomena extended on a continental scale. So when we refer to continental scale, we know what do we mean by continental scale. It means a phenomena or an extension that is up to thousands of kilometers. A huge extent is conventionally referred as continental scale in geography. So a simple land breeze and sea breeze phenomena extending over the large scale, over the continental scale, was termed as the monsoonal phenomena by Halley. Like, what was of mechanism? Says, let's take an example here. So suppose this is a summer condition. During summers, the temperature of continents increases. It's very high. Here it's very high, and therefore intense low pressure develops in the interior parts of continents, right? Because if the temperature increases, What happens if the temperature increases? Air masses get lighter and therefore rise up. And rising air masses therefore form a intense low pressure zone. Now, the differential heating of land and water takes place. The differential heating of land and water is because of difference in the specific heat of continent and oceans. Continents have very low specific heat, that is the heat required to increase the temperature of a unit mass of substance by 1 degree Celsius. In simple terms, it determines how quickly a surface becomes hot or how quickly it cools down. So continents have low specific heat in comparison to water. So that means the temperature on the continents is going to be higher and therefore develop low pressure. But if we compare it to the surrounding water bodies, that is oceans, temperature is relatively less and relatively higher pressure zone. So surrounding water bodies have low temperature. I am repeating the reason for that differential heating. It is that land heats much faster than the water bodies. So this causes air to move from high pressure to low pressure. Right? This is nothing but a sea breeze phenomena, and it brings moisture along with it and can cause rainfall. This happens during summers. What about winters? Right? Suppose this is the continent. What about winters? See, as they say, good absorbers are good emitters. If a surface heats quickly, it also loses temperature quickly. The rate of cooling on the continents is much faster than the rate of cooling in water, because water has a higher specific heat and therefore it can retain heat for a longer duration of time. Right? Continents cannot retain heat. So if you look at winter conditions, so temperature on the continents decreases and this forms high pressure condition over continents. Right? It's relatively higher pressure over continents. But what about water masses? Higher temperature. That's because, I'm repeating, it's not that heating effect has taken place, oceans have been heated. No, it is the cooling effect on the continents is much higher than the cooling process over oceans. So now this should lead to the relatively low pressure conditions over water bodies, and when we know that winds move from high pressure to low pressure, right? High pressure to low pressure. So Halley observed that because the heating and cooling is too intense in the Indian subcontinent, it is due to this reason that the temperature is different, it is due to this reason that pressure difference arises to an extent that it can carry winds from Bay of Bengal to the Punjab Haryana region, or from Arabian Sea to the interior parts of the plateau, that is central India. Right? So exactly the simplest description would be something like this. So temperature is high over continents are low. But does it happen? Can a sea breeze be so strong that it can carry moisture till the interior parts of continents? Or land breeze move from Punjab to Bay of Bengal or Arabian Sea? So he was criticized for presenting a very simple concept for a complicated phenomena, a very simple theory, because land breeze and sea breeze cannot extend for continental scale. After all, they have been generated just by the differential heating and cooling of continents and water bodies. So this cannot be that intense to cause rainfall in these areas. But credit must be given, because one of the first, you can say, scientific concept was presented by Halley to explain monsoon. And now you will observe that many geographers have borrowed the concept, same concept of differential heating, and explain, the entire concept of monsoon. Like, for example, if we go by the next theory, then we have Hadley's concept. All those who have studied tropical winds, who have studied the tricellular model, right? All those who have studied the planetary winds must have heard this name Hadley, because we have a tropical cell named as a Hadley cell. According to Hadley, he presented a concept of air mass theory. Right? Air mass theory. And the concept is quite simple. This is, suppose, two hemispheres, northern hemisphere, southern hemisphere. So, due to the presence, rather vertical sun rays over Tropic of Cancer, slanting sun rays are there towards Tropic of Capricorn. In short, if we have summers in the northern hemisphere, at the same time, winter conditions prevail in the southern hemisphere. Right, a very preliminary concept of differential, rather, the movement of sun rays towards north and south, apparent shifting of sun rays to the north and south. Right, so because it's a summer conditions in the northern hemisphere, there should be low pressure zone in the tropics of northern hemisphere. So it is due to the fact that sun rays are vertical near Tropic of Cancer. So in the tropics of northern hemisphere, right, due to higher temperature, low pressure conditions prevail. Whereas at the same time, if you look at the southern hemisphere, in this region, in the tropics of southern hemisphere, pressure should be higher. So high pressure conditions prevail in the southern hemisphere. So we know winds will move from high to low, high pressure to low pressure, and also incorporated the concept of Coriolis force. What is Coriolis force? A pseudo force applied by the virtue of rotation of earth, right, and because of this force, we apply a law called as Farrell's law. According to Farrell's law, anything moving in northern hemisphere is deflected to the right of its direction. Anything in the southern hemisphere is deflected to the left of its direction. It is right and left in north and south, northern and southern hemisphere of the moving object, not observers left and right, right? Moving surface. So winds in southern hemisphere, when they move from, say, high to low, get deflected towards left of the direction of the wind, and these are called as southeast winds, exactly southeast trade winds. But we know that they'll cross equator and move towards low pressure zone, right, in the northern hemisphere, because intense low pressure conditions prevail there. So the same southeast winds get deflected towards right and become southwest winds. Why do they deflect towards right? Is because of Coriolis force. It deflects winds towards right in northern hemisphere. So southeast winds become southwest winds, right? This is how southwest monsoon reaches to India according to Hadley's concept. So it is the air masses carried by these southeast and southwest winds which can cause rainfall. What happens during winters? Right? During winters, conditions reverse. And what is the condition? That we have low pressure in the southern hemisphere. Right? Low pressure in southern hemisphere. Why? Because if we have summer in the south At the same time, winter conditions prevail in the northern hemisphere. Sun rays are vertical at Tropic of Cancer. I beg your pardon, Tropic of Capricorn, 23.5 degrees south. And exactly in northern hemisphere, due to winter-like conditions, there's a high pressure. Temperature is low, air masses get dense, they subside to form high pressure conditions. So winds will move from high to low. In the northern hemisphere, deflection is towards right of the wind. Right of the wind. So they become, these are northeast winds. But as they cross equator, as these winds cross equator, deflection is towards left of the moving object. So these northeast winds now become northwest for southern hemisphere. This is the concept. This theory was given by Hadley to explain the formation or the origin of monsoon. So what is monsoon? According to Hadley's concept, so this is summer conditions. Because of this, we have a very intense low pressure zone in the upper part in the northern hemisphere, and during winters, intense high pressure zone. So these southwest winds will become, southeast winds become southwest after crossing equator, and here during winters, these are northeast winds. So how do we understand monsoon here? We understand monsoon or visualize this theory, monsoon as mere modification of trade winds. Modification of trade winds. So it is southeast trade winds which become southwest, right, and northeast trade winds cross equator and become northwest. So what is happening primarily is the changing, position of sun rays. Apparent shifting of sun rays is also inducing a change in trade winds. So same southeast become southwest, northeast become northwest. This was very true to a great extent because Hadley had worked mostly in the tropical cells. A slight modification in modern theories. In modern theories, one of the prominent theory that comes is the dynamic concept given by Fawn. Right? Fawn's concept. What about Fawn's concept? As the diagram suggests here, right, what is one change that he brought in? He used the dynamism of intertropical convergence zone. Right? Intertropical convergence zone. I want all of you to observe that this is intertropical convergence zone. It has a bend towards north. It has a bend towards north over Indian Peninsula, this region. And then again it shifts normally towards equator when it passes through Arabian Sea. Right? It shifts normally. A food for thought. By the time we reach up to why did this happens, keep it in mind, think about it, right? You might get the answer. So let's explain what he said. The theory was very much similar to what already was explained. But he explained with the dynamism of intertropical convergence zone and little more detailed concept. So first is, suppose this is Earth and this is the equator, and here we draw Tropic of Cancer, and this is suppose Tropic of Capricorn. Well, we don't require Tropic of Capricorn in this diagram, so I'm removing this. We focus only on the Tropic of Cancer, that is 23.5 degree north. So during summers, Sun rays, this is summer condition. Sun rays are vertical at Tropic of Cancer. Clear? So air masses in contact to the surface will rise up, like what happens at equator usually, equatorial low pressure belt. So they rise up, right? Suppose these are air masses, they rise up. Why? Because warm air masses are lighter, therefore they continuously expand and rise up. Move towards north, towards south, right? Air masses rise up and then they expand towards polar areas due to energy difference, and then subside because the subsidence occurs because the movement is at the expense of energy. The more it travels in the upper troposphere, cooler it gets. When it becomes very cold, dense, subsides, and thus forms a high pressure zone here called as subtropical high pressure zone. Southern hemisphere also, due to subsidence, there will be high pressure zone called as subtropical high pressure zone. Right? Subtropical high pressure zone. Why? Because there is a subsidence that happens, and due to subsidence, the atmospheric pressure increases here. Now, usually this equatorial low pressure belt that is formed at equator, that is formed at Tropic of Cancer this time during summers, is formed at equator, right, during equinoxes, and these pressure belts, subtropical high pressure belts, are formed at around 30 degree north and south. But this time during summers, as the vertical sun rays are near Tropic of Cancer, right, equatorial low pressure belt has shifted to the north. Subtropical high pressure belts also shift little north of their position. So they are formed at around 40 degree north latitude and around 20 degree south latitude. Right? It's an approximate latitude, of course. So usually they are found at 30 degree north, 30 degree south. But what happens during summers? There is a northward shift of pressure belts. So from 40 degree north, from 30 degree south to 20 degree south latitude. Right? This is how pressure belts are positioned during summers. Now we know that winds move from high to low, subtropical high pressure belt to equatorial low pressure belt. I am repeating, where is ELP? Where is equatorial low pressure belt? At 20 degree, close to 20 degree north latitude, Tropic of Cancer. So now, as winds move from subtropical high to equatorial low, deflection will be towards left in the southern hemisphere under the influence of Coriolis force. Then again, same thing, as they cross equator. Why do they cross equator? Because low pressure is to the north of equator. So as they cross equator, deflection will be towards right of the wind. So same southeast winds actually become southwest. Winds are always named by the direction they come from. We should know this point. Right, surface winds, if they come from east, easterlies, west, westerlies, southeast, northeast. So direction they come from, right, that is how winds are given names. So now southeast winds become southwest. From the northern hemisphere, subtropical high to equatorial low, deflection will be towards right of the wind. I am repeating, not of the observer's right. So if air is moving from poles to equator, deflection will be towards west. That is towards right of the moving object, right? So here, this is the direction of northeast winds, right? This is northeast winds. Now both northeast winds and southwest winds converge this time around at equatorial low pressure belt, that is at Tropic of Cancer. So this is called as this northern ITCZ, northern intertropical convergence zone, where southwest winds are converging with the northeast winds. So India will also get rainfall. Now Let's see second aspect. During winters, what happens during winters? Right, this is suppose equator. Right, 0 degree. Sun rays are vertical near Tropic of Capricorn. Right, near 23.5 degree south latitude. Right, 23.5 degrees south latitude. Now this will be the region of ELP now, equatorial low pressure belt. It is shifting southwards. So now air masses rise from 23.5 degrees south, right, will move towards south, will move towards north and subside similarly. This time the movement, rather the pressure belts shift south of their position. So now it will be formed at 40 degrees south, theoretically at least, right? And in the northern hemisphere it is formed at around 20 degree north latitude, the subtropical high pressure belt. Winds move from high to low, subtropical high to equatorial low. Now this time northeast winds will get deflected towards right. These are northeast winds in northern hemisphere. So this time northeast winds cross equator because low pressure is to the south of equator. So as they cross equator, deflection is to the left of the winds. Left of the winds. So northeast winds become northwest. So the same wind that gets rainfall in India because of northeast winds causes rainfall as northwest monsoon in Australia or in southern hemisphere, which converge with southeast winds, because this time around southeast winds will not reach up to equator. So this is called as southern ITCZ, Southern Intertropical Convergence Zone. Now have you observed exactly the same thing is happening in the northern hemisphere, and that comes back to the southern hemisphere. It's just the apparent shifting of sun rays which is changing the pressure belts, and the corresponding change in the pressure belts is bringing change in the pattern of the winds. This is how southwest winds, southwest monsoon and northeast monsoon reaches to India. Right? So now let's go a little detail into this and try to understand what happens over the Indian peninsula. Now, did you get the answer for this? Why is low pressure shifting to the north? Why is this low pressure bend? Remember, isobars over continents bend or shift towards poles during summers, right? During summers. Isobars, lines joining places with equal pressure, they bend towards north, right, because of the same differential heating and cooling, and also the pressure accordingly changes over between the continents and oceans. So it is not that oceans will have the same pressure as that of continents, right? It will be different. So why is it shifting to the north? Is because of intense or continentality, right? Continental effect. What is continentality? What is the effect of continentality? Again, I am bringing that concept back. Temperature is high because specific heat is low over continents. Intense low pressure zones develop. In the northwestern part of India, right, this part of India, the temperature is very high during summers. So low pressure does not only remain confined to the Tropic of Cancer, but also will be towards north. So there is a kind of northward bend to the ITCZ or to the equatorial low pressure belt. right? Due to which we can say that the temperature is high and low pressure reaches to the Indian part, and that is how southwest winds reach India. Summers conditions are different. Sorry, winters conditions are different. We have high pressure region over here, subtropical high pressure belt, and these winds will, northeast winds, move towards south and bringing rainfall to the eastern coast of India and not to the western coast. Right? We will discuss the distribution of monsoon, distribution of rainfall little later. But if monsoon is so simple, right? Why then is it unpredictable? Why has it been such a big question, right? Or why is it so difficult to predict the monsoon? There are so many other concepts, so many other factors involved that affect monsoon directly or indirectly. And to explain this, we have next theory, the recent theory, jet stream theory. Right? Let's describe what is jet stream theory. See, jet stream theory is actually about the various types of jet streams which blow in upper troposphere and also reach to India. What is a jet stream, first of all? Right, we have discussed this in our discussion in climatology. Jet stream are these bands of fast air circulation in upper troposphere. In upper troposphere. Now these winds even have a velocity of 150 kilometers and they can reach up to 400 kilometers per hour. And why are they fast? That's because less friction. Right? Because of friction is very less. Right? Even the highest peak of the world is under 9 kilometers. So there's no major obstruction in the upper troposphere. So due to less friction, they can move fast and can also have a huge effect, rather huge extent. They can extend up to continental scale. And there are many types of jet streams. We are just focusing on just 2 jet streams today, right? Rest in climatology, we have already discussed those. So what about the jet stream? It's about, right, first jet stream that affects Indian monsoon is subtropical westerly jet stream. Subtropical westerly jet stream. Just now, some time back, I said, what are the winds are named by the direction they come from. Right? Winds are named by the direction they come from. So this is quite evident that it comes from the westerly sides, right? Western direction. And subtropical, that means its latitude has been defined here. Latitude is clear. So it is within this 30-35 degree latitude. And during summers, the position is little north of its usual, right? Usual means equinoxes. And during winters, it shifts little south of its position. So keep this in mind. Subtropical westerly jet stream, that it shifts little north and south. During winters, it comes in almost in the same latitude as that of Himalayas, right? The subtropical westerly jet stream, Himalayas. And Himalayas causes obstruction and therefore bifurcates the jet stream in 2 branches. One to the north of Himalayas, another to the south of Himalayas. Right? What happens by that? We'll discuss this. But before we continue, we proceed. understand that in subtropical areas, due to the temperature or thermal contrast between tropical cell, that is headless cell, and the feral cell, there is a strong jet of air that is produced in upper troposphere that moves from west to east. And we have discussed what is jet streams. We call that a subtropical westerly jet stream. Right? So, air masses at equator rise up, right? They subside, forming this subtropical high pressure belt. So, as they rise up in upper troposphere, they move towards north and south, and also one of the part gets deflected towards right under the influence of Coriolis force. So, there will be the subtropical westerly jet stream that circulates Earth at this latitude. So, during winters it comes in contact to Himalayas, and as I said, it gets bifurcated in two branches. One goes little south of Himalayas, the another goes to the north of Himalayas. It also is responsible for bringing western disturbances to India, but we will see that western disturbances later. Right, that's a separate topic altogether. So let us see what happens over India. This is suppose the northern part of India. I'm just briefly northern part of India, and what is happening here is that jet stream gets bifurcated as it comes under the influence of Himalayas. One is the northern branch, another is the southern branch, north of Himalaya and the south of Himalayas. Please consider one more point. What is the position of subtropical westerly jet stream? Right, that is all we require. What is the position of subtropical high pressure during winters? It's around 20-25 degree latitude. Right, this is the subtropical high pressure belt. What is the latitude? I am repeating, please think. The latitude is around 20-25 degree north latitude. So this is the position of subtropical high pressure belt also. The jet stream is in upper troposphere, right? It should have passed, but because of that obstruction, Himalayas sends it towards south and one towards north. Now, suppose there's a strong jet passing in the upper troposphere, a aeroplane or a fast moving aircraft. The air underneath the aircraft, underneath that jet of air, will get compressed because it is passing. So, what will happen to the air underneath that? Will get compressed. And due to compression, it will subside, like it will sink. Not because it is getting cold, it's because when the jet of air passes, the air underneath the jet of air will get compressed. And due to that compression, air should sink. Right? Due to that compression, air should sink from upper troposphere. And if air sinks, right, it subsides. What happens to the high pressure zone near the surface? It intensifies. Already there is a high pressure zone. Already now we have discussed that there is a apparent shifting of sun rays towards south and apparent shifting of, there is a shifting of pressure belts also to the south. So there is already a high pressure zone formed at around 20-25 degree north latitude, but then a jet of air also passes over it. What will happen to the air underneath that? Gets compressed, subsides, intensifying the subtropical high pressure belt. Now, if the subtropical high pressure belt intensifies, think what should happen to the speed of the wind then? Right? This is the direction of the winds during winters, northeast winds. So, high pressure zone intensifying, air movement will increase, rather the speed of the northeast winds will accelerate, will intensify. So what is the role played by the jet stream? First jet stream that we are talking about, westerly jet stream that we are talking about, it intensifies northeast monsoon or winter monsoon. Because it is during winters that they reach to this part of India, intensify high pressure zone. So a subtropical westerly jet stream causes intensification of subtropical high pressure belt, which in turn causes the intensification of northeast monsoon or winter monsoon. So you should be able to understand this, how bifurcation and what happens because of that bifurcation. What happens if a jet of air passes over a region? Obviously the surrounding air nearby the region will be getting more dense. Underneath that will get dense and high pressure intensifies. So with the arrival of jet streams, subtropical westerly jet streams in India, right, the high pressure conditions intensify. Right, high pressure conditions intensify, leading to strengthening of northeast monsoon. This is first effect of jet stream. Let's see the second jet stream and the effect of that jet stream. Right, see, you have to understand that concepts, you have to build concept. It's not something, I'm repeating, it's not a rocket science in geography. Right, provided you have very clear concepts, and once you understood these concepts, once you have imbibed those concepts, it will remain with you. And if a question is asked about jet stream in monsoon, check out your question papers. There have been previous years where the question has been asked about jet stream in monsoon. Straightforward answer, draw the diagrams, write these theories carefully, and you will get marks. Objectivity. Alright, let's see the second jet stream, called as tropical easterly jet stream. To explain the jet stream, this particular jet stream and the effect of jet stream on monsoon, see, when an air rises continuously, you must have seen smoke rising from the chimney and creating a dense cloud of smoke over the chimney. That's because density of air is very high there. And due to increase in the density, right, due to increase in that high pressure condition, which we also called as anticyclonic conditions, winds deviate, winds move away from each other. And they move away from the centrifugal pattern of the wind. Right? If there's a high pressure, wind will always be having outward flow. If there's a low pressure, right, intense low pressure, winds will have centrifugal pattern. It will be inward. And this is common observation. So what happens over Tibetan plateau? And we are talking about summer conditions. Should be clear that it's about summers that we are talking about. During winters we have this phenomena going on during winters. Westerly jet streams, right? Intensifying northeast monsoon. Now we are talking about, summer conditions. What happens during summers? The temperature of Tibetan plateau increases. This region is the Tibetan plateau region. The temperature is very high. Why is it high? Understand the condition of Tibetan plateau. Number one, it is desert, dry region. So cloud cover is negligible, especially during winters. Second, vegetation cover is also less. Third, it's very high. So the insolation will be very intense, right, during summers. So due to strong insolation and low specific heat of continents, air in contact to the Tibetan plateau becomes very hot and therefore rises up. Warm air will always rise. So Tibetan plateau has been compared to a heat engine generating strong air currents. Why heat engine? It is because the temperature of Tibetan plateau increases, the surface becomes very high, very hot, and air in contact with the surface also becomes warm, therefore air currents are generated. So continuous upward movement of air will take place. What will happen in the upper troposphere in that case, if the movement is taking place upward, like there's a high pressure condition over there? Anticyclonic conditions, right? Anticyclonic conditions, that is intense high pressure zone formed in the upper part of Tibetan Plateau, upper troposphere of Tibetan Plateau, right? Exactly, that is what is mentioned here, anticyclonic conditions. So because of this anticyclonic conditions, winds move outwards, centrifugal. Coriolis force says in northern hemisphere deflection of wind is towards right of the wind, right? So due to this outward flow, a clockwise circulation develops over Tibetan Plateau. A clockwise circulation develops over Tibetan Plateau. In the upper troposphere of Tibetan Plateau. When I say Tibetan Plateau, it is the upper troposphere of Tibetan Plateau that we are referring to, right? So there is a continuous clockwise circulation. Why is it so? I am repeating. There is a heat engine that produces these air currents, increases the pressure conditions over, increases the density over that, and creates the circulatory effect, or Coriolis effect, causes this clockwise circulation. Now, nearly at the same latitude, right, almost at the same latitude, we have second aspect, right, almost at the same latitude, there is a strong jet of air that goes towards west, right? There's a strong jet of air which is called a subtropical westerly jet streams. We just discussed that. Subtropical westerly jet stream. So due to this clockwise pattern of the circulation of Tibetan Plateau, a part of jet stream enters Indian Peninsula from the east. A part of jet stream, this part here, enters Indian Peninsula, Indian subcontinent from the east. The one that I have drawn with the green is in the upper troposphere. Right? Understand the connection. There's a circular movement. There's a clockwise circulation developed in the upper part of troposphere, rather upper part of Tibetan Plateau, and the subtropical westerly jet stream, which anyways blows in the region, gets modified by the same circulation. A limb of that enters India from the east, called as tropical easterly jet stream. Called as tropical easterly jet stream, which causes intensification of monsoon. It pushes Bay of Bengal branch towards west. We'll see that later. Understand the jet stream. So how is tropical easterly jet stream affected? First of all, understand the intense high pressure over Tibetan Plateau forms clockwise circulation, and therefore modifies the subtropical westerly jet stream. A part of that enters India from the east, called as tropical easterly jet stream. So this is how entire subcontinent gets affected by jet stream. This jet stream crosses over Indian Peninsula, sinks towards west, intensifying this entire phenomena. Clear? So there are two jet streams which play an important role. Number one is the subtropical westerly jet streams during winters. Number two is tropical easterly jet stream during summers. Both intensify Indian monsoon. Right? Then there is one more aspect of Tibetan Plateau. Right? There's many geographers like Professor P. Koteshwaram, who actually explained the role of Tibetan Plateau in a different manner and said that Tibetan Plateau also intensifies Indian monsoon by generating an intense high pressure zone along the western part of Indian Ocean near to equator. Right? What is that? Let's try to understand. But to understand this, let's say this is Tibetan Plateau, this is Greater Himalayas, Middle Himalayas, Shivaliks, its northern plains, Peninsular Plateau, and so on. Right? This is the northern side of Indian Peninsula. This is the southern side. So you stand near Pakistan, look towards India, you will find the topography would be something like Plateau, Tibetan Plateau, Himalayas, northern plains, Peninsular Plateau. Right? What we have mentioned so far is that Tibetan Plateau becomes very hot. So air masses rise from Tibetan Plateau. Right? They rise from Tibetan Plateau and can move in any direction. So ignore this clockwise circulation right now. For a moment we are ignoring this Coriolis effect. So it can go in any direction. One of the limb out of many will cross equator, and by the time they travel so much of distance, the air will get cooler, therefore denser, and then subside to the south of equator. To the south of equator. And wherever air masses subside, it forms a high pressure condition. We know that subsidence of air will form high pressure condition. So what is happening? A current of air we are considering, that is, it rises from Tibetan Plateau, moves in all directions. We are just picking up one direction, the one that goes towards south. So crosses equator and then subsides. The subsidence of this air will form high pressure zone. And this is in the upper troposphere, and when high pressure zone is formed in the lower atmosphere, lower because of sinking. So obviously from high pressure winds will move towards the low pressure zone. Right? This is easy to understand. Wherever the atmospheric pressure increases, air will move away from that. Now where is it happening? Where is this air mass sinking actually? Where is this high pressure being formed? Right? If you look at the map, right? If we see the map, let's see where is it formed. This is suppose Africa, Arabian Peninsula, Indian Peninsula, and this is the Malaya Peninsula. It's the Mediterranean Sea. So it's something like air masses rise from Tibetan Plateau here. They rise from Tibetan Plateau. I'm saying move in all directions, right? But I'm just ignoring that Coriolis effect right now. So they cross equator and sink in the western part of Indian Ocean. Right? They sink in the western part of Indian Ocean and form a high pressure zone. We have this high pressure zone called as Mascarene highs to the south of equator, which is also formed because Walker circulation happens in Walker cell, subsides there. Western limb of Walker cell also subsides here, so called as Mascarene highs. So if this is equator, let's say it sinks to the Mascarene highs is formed on the western part of Indian Ocean, little south of equator, near Mascarene Islands. It's not far away from equator. But anyways, if the pressure is high, if the Mascarene high has been formed, obviously the wind speed will be higher, right? So winds from the surface, near to the surface, move towards low pressure zone. And where is the low pressure zone? In Indian subcontinent, right? So from there, winds will move towards low pressure zone, which is called as cross equatorial jets. Right? It's like circulation. Air mass is rising from here, sinking here, and they kind of coming back towards increasing the southwest monsoon again, intensifying southwest monsoon. This all happening in winters. I beg your pardon. This all is happening in summers. Right? heating of Tibetan plateau. So southwest monsoon, cross equatorial jets, they cause or responsible for sudden burst of monsoon. Sudden burst of monsoon over Indian peninsula. So masculine high, see what is Indian plate, Indian monsoon. Monsoon is getting intensified because of so many physiographic features that India has. It's Tibetan plateau that is intensifying Indian monsoon. So if there is any change over Tibetan plateau, it will have an influence over Indian monsoon. Can we understand this particular point? If there is any change in the Tibetan plateau, it will have change over, it will affect Indian monsoon. For example, if the Tibetan plateau becomes very hot, or let's say reverse it, if there is an ice cover over Tibetan plateau, the heating of Tibetan plateau will not take place even during summer if there is an ice cover. So this jet streams etc. will not be formed. This masculine high will not intensify, and India will experience poor monsoon. But if Tibetan plateau is heated more than the normal, because you know that global warming is showing effect over Tibetan plateau as well, the entire phenomena then will get intensified. Whether it's masculine highs that gets intensified, whether it's the tropical easterly jet stream that will accelerate. So because all these phenomena are related to Indian agriculture, it will affect India and Indian agriculture immensely. Clear? This is related to the origin of Indian monsoon. Right? How monsoon of India originates and what are the recent theories related to origin of monsoon. Right? Tibetan plateau. Okay. So now we'll look at the distribution of monsoon, southwest monsoon. So here when monsoon reaches to India, two branches called as, first is the Arabian Sea branch, Arabian Sea branch. Second is Bay of Bengal branch. Arabian Sea branch strikes to Western Ghats and therefore results in heavy rainfall in monsoon. Right. Causes heavy rainfall in western part of Western Ghats, in Malabar coast, in Karnataka, in Goa, in Maharashtra. Right. It's the orographic effect. What is the orographic effect? When an air mass rises because of a barrier, right? When it rises because of a barrier, right? Temperature decreases, condensation happens and it receives heavy rainfall. Whereas the other area remains, leeward side remains a rain shadow. So this area of Western Ghats, eastern part is the rain shadow area. Because we know that Western Ghats are like wall-like features, perfect wind barriers. So they do not allow moisture to reach to the other end. So they cause very heavy rainfall in the western parts. So Western Maharashtra, Goa, Karnataka, they get heavy rainfall along with Kerala. But Vidarbha, eastern part of Karnataka, Telangana, these are the rain shadow areas of Western Ghats. Right? Then Arabian Sea branch further moves to the north, causes rainfall in Gujarat, but moves parallel to Aravalis. Aravalis, right, parallel to Aravalis. The orientation of Aravalli is from southwest to northeast. So Arabian Sea branch will also move from southwest to northeast. That is also that is the direction of Arabian Sea branch, and therefore Aravalis are not effective barrier to cause rainfall. Number one, the elevation is less, and number two, they are parallelly aligned to the southwest monsoon wind. So they don't offer any major obstruction, and therefore you can see the western part remains dry. Right? Due to intense low pressure zone over here in northwestern part, this Arabian Sea branch gets diverted towards that. Right? It also happens, we know what is the extent of Western Ghats from mouth of Tapi to Kanyakumari. So that it is also the reason why north of Western Ghats, north of mouth of Tapi, Arabian Sea branch enters in interior parts of India and also causes rainfall along Satpura and central India. Eastern side, Bay of Bengal branch moves parallel to the eastern coast. So if it is parallel, it is quite understandable that it cannot cause much of the rainfall there. Right? It goes parallel to Eastern Ghats. So Coromandel coast remains dry during summers. Right? Because Bay of Bengal branch moves parallel to eastern coast. But as it keeps moving towards north and comes under the influence of the low pressure that has been developed in the northwestern part of India. Just now we said that the ELP would be something like this. It has a northward bend because of the continentality of this northwestern part of India. Temperature is very high in this part of India. So low pressure will also be towards north. Bay of Bengal branch gets influence, gets attracted by the low pressure zone, and will start moving towards west. It is attracted by the intense low pressure zone of northwestern part. So it's very obvious that rainfall will keep reducing towards west. Right? Orissa, Jharkhand, Chhattisgarh, these regions will receive much higher rainfall, including Bengal and UP also, than northwestern part of India, this Punjab, Haryana, Jammu and Kashmir. By the time moisture reaches over the region, or this part, amount of rainfall reduces, amount of moisture reduces. Then Bay of Bengal branch enters northeast, and northeast is completely a hilly topography, right? A hilly topography. That is, it has Meshumi, Abhor, Miri, Dafla to the north, that is Himalayan regions, and also this Patkaibam, Naga hills, Manipur hills, Tripura hills, Lushai hills, Garo, Khasi, Jaintia. It's hilly terrain. So when moisture winds, when they enter in this hilly topography, they're trapped, right? Moist winds are trapped, resulting in immense rainfall in northeastern states, causing very heavy rainfall in Nagaland, Manipur, all these states, in Assam. Why? Because to the north is Himalayas, so they can't escape. There's a strong barrier to the north. Then we also have the eastern Himalayas, which is hilly. So moist air masses, they keep striking to hills, they keep rising up and can cause rainfall. Now the trapping effect becomes very intense in Meghalaya, right? Because to the north of Meghalaya is Himalayas, and Garo Khasi hills form a funnel shaped corridor of hills. So what happens is that if we talk about the Himalayan region here, to the north, suppose this is Himalaya, right? Exactly to the south lies these Garo hills, right? Garo hills, Garo Khasi hills. So moisture strikes to Himalayas, wind strikes to Himalayas and gets pushed and then enters Garo hills. So this effect, because of the funnel shape of the Garo hills, is also called as funneling effect. Funneling effect. No scientific, it's just a symbolic term, because winds form that funnel shaped corridor through which moisture passes, keeps striking, keeps causing rainfall. So that shows why Meghalayan plateau gets so heavy rainfall. It's like no escape for moisture, right? Once they enter in these corridors, they keep striking to the hills and keep causing rainfall. So it's kind of cyclic process, right? That makes the region one of the most, in fact, the most rainy place on earth. Right? This is the distribution of Bay of Bengal branch. Why Bay of Bengal branch accelerates towards west is because of the jet stream, the tropical easterly jet stream that prevails in the region during summers pushes these moisture winds, this Bay of Bengal branch towards west. Now this is about monsoon, distribution of monsoon. But when we look at the effect of monsoon, see, we have to play we have to understand that prediction of monsoon is not so easy. Although we have so many missions, if you look at the current aspect, towards the end we will be moving towards a current aspect, right, when we complete Indian climate. In that we have had so many projects like Mission Monsoon in 2012, launched in 2012 by Ministry of Earth Sciences, which was aimed to predict monsoon, because it is very important as our sowing and harvest is largely dependent upon the monsoon cycle. So important. Second aspect, if you see, recently an Indian Ocean Research vessel was launched called as Sagar Nidhi. This Sagar Nidhi was in 2018, launched in 2018, a joint expedition of Indo-US joint expedition, which is aimed at presenting models for forecasting and understanding monsoon, rather the vagaries of monsoon in Bay of Bengal, right? Indian research vessel, to understand that, because it's important to collect data from there. What data, like meteorological data, temperature, pressure, how does it change, what is the direction of the winds, what other parameters can be set up to predict monsoon. And last 2019 there was one more addition to that. We are focusing on National Supercomputing Mission to improve our long range and medium range prediction. Now, using this supercomputing methods, we will collect data, and also it will be hydrological data, it will be meteorological data, and changes in the Indian Ocean region. And based on that, it will be better for us, right? Rather, the computing supercomputers will help us to predict monsoon in the best possible manner. Apart from that, right, we have to be prepared for the vagaries of monsoon, because climate change has seriously impacted Indian monsoon. Right, in the years when it is normal, it is more than the normal. When it is dry, it is more than dry, right, more than the average drought year. So therefore, prediction of monsoon becomes very important, and preparation also becomes very important. Right, in our discussion on floods and droughts, we have already discussed what floods have done, how to manage floods, concept of sponge cities, etc. important. Drought management is equally important. So we have to be prepared with these plans, right, along with the proper prediction of monsoon. Right, that is it. So see you in the next discussion, right, related to Indian climate. Right, thank you.